Production control enables the machine user to configure production parameters, track the production status, and intervene in case bad parts are being produced. Let's take a closer look on the page itself. The page consists of the following areas. Counter area, where the user can set the production targets and see the general production overview. Material area, where number of mold cavities and part weight can be set. Bad parts control area, used to control when the production should be interrupted in case too many bad parts are produced. Air valve separation area, used for part separation control. This area is only visible in case the option has been purchased. Startup scraps area, where the user can control scraps on the beginning of production. Now that we have the page overview, let's go and see how to use the production control. Let's start by resetting the previous production data. This is done by clicking the reset buttons. Let us zoom in a bit on the counter area, for a better view. The area consists of two parts. On top we have the shift information, and on the bottom the total production info. For example, we want to produce 100 parts per shift, but we want to limit the total production to 1,500 parts. To do this, we need to set production targets. This is done in the highlighted input fields. Even though the machine is already in production, we can see that the counters are not changing. For the parts to be counted in production control, the checkbox marked in the top needs to be selected. Now with the beginning of the next cycle, we will also notice that the counter information is changing. In the start time field, a date and time stamp indicates when the first part was produced. Next to it, we see the total number of parts. This includes both good and bad parts. Good parts are those that satisfy the quality settings of the quality table and the quality graph. The bad ones are those that are outside of those tolerances. Remaining parts tells us how many good parts still need to be produced until the end of production, and in the last cell we see how long that will take. As mentioned a couple of moments ago, if a bad part is produced, the counter for bad parts will increase. On top of that, the user will also be warned that a bad part was produced, by an alarm message. It is also possible to calculate material consumption. For this, however, number of cavities, and part weight need to be set. Based on these values, after each cycle, the amount of material used up to that point is calculated, as well as the required amount to produce the remaining parts. A cavity represents how many parts are produced inside of the mold each cycle. This means that for a single cavity mold, the quantity of consumed plastic granulate equals the part weight. If, however, the mold has more cavities, material required per cycle is going to be multiplied by number of cavities. Another important feature is the continue production function. The checkbox to activate it is located in the top right corner of the page. Normally, once the production target is reached, the machine stops. But, if this option is enabled, once the production target is reached, the machine will still continue producing parts. We can see this behavior in a side-by-side view. On the left side, the option is disabled, while on the right, it is enabled. Once the production limit is reached, we see that on the left there is no more machine movement, while on the right side, even though the limit is also reached, the machine continues producing. We showed how the machine can stop if the production target is reached. But let's take a look at how we can prevent material waste if too many bad parts are being produced. In the highlighted area, we can impact how the machine behaves in this case. In the first case, by setting the number of bad parts, we are limiting how many total bad parts can be produced before the machine stops. For the function to be active, the checkbox related to it also has to be activated. Once the limit of bad parts is reached, the machine will stop production, and warn the user about it. This is the most simple way to stop the machine if bad parts are being produced. Let's now take a look at a more advanced way of production control. What if the bad parts limit is higher, but for some reason, the machine starts producing many bad parts in a row? This could indicate that something has gone wrong, but until the absolute limit of bad parts is reached, a lot of material could be wasted. In the highlighted area, we can impact how the machine behaves in this case. These two options monitor the last 10 and 100 shots. If in those monitored shots, the number of bad shots reaches the set limit, automatic mode will stop. For example, if 6 out of 10 last shots are bad, production stops and warns the machine operator about it. The same principle is used for the last option, only the monitored shot range is 100. The next highlighted area of the page is only visible if the special option is purchased with the machine. If the option is enabled, it is possible to separate good and bad production parts, using an air valve controlled diverter. If end position detection is available and the checkbox is marked, it will also check if the diverter has reached the end position, and if not, after some time it will set off an alarm to indicate so. Located on the bottom of the page, we can see the settings for startup scraps. Startup scraps represent the number of parts that should be discarded at start of production. This function has a standard and an advanced variation. In standard form, the function just needs to be enabled, and number of scraps set. For example, 3 parts. Now when we start the production, the first 3 parts are going to be discarded as scraps. They won't count as good or bad parts in the production counter, as can be seen. In the bottom, next to the scrap input, we can see how many scrap parts have been produced. Once the set amount of scraps has been made, normal production starts. The advanced version of startup scraps gives the machine operator the possibility to set different amount of startup scraps, based on how long the machine was in standstill. For example, if the machine was inactive for more than 5 seconds, we will make 2 scrap parts. If it was inactive for more than 20 seconds, then we will make 3 scraps, and if it's more than 120 seconds, then 4 scrap parts. Underneath the time inputs, we can see a timer that tells us how long the machine was in standstill. Since it was in standstill for 26 seconds, the second inactivity period should be active. Once the first cycle is finished, the indicator light will turn green, to show which setting is going to be executed. Finally, when all the set scrap parts have been produced, normal production will start. We hope this video tutorial was helpful. If you have any other questions regarding production control, please leave a comment below, or contact us directly through our customer service channels. Thank you, and have a nice day.